As mentioned earlier, for the trig functions to have inverses that mathematically make sense, we had to restrict the outputs to certain ranges. But sometimes when you're looking for angles, they may be out of that range, which is okay because trig functions happen to be periodic, so finding one solution means that you can find a bunch of the other solutions. So let's look at examples of how to deal with such situations. Find all solutions for angle theta between 0 degrees and 180 degrees that satisfy this given condition. Now the first angle is pretty much obvious. I just go sine inverse of 0.45. Sine inverse of 0.45 gives me roughly 26.74 degrees. Now at this point, the way to think about it is sine theta is positive. So where is sine theta positive? So the answer is quadrant 1 and quadrant 2. The quadrant 1 angle we already found is 26.74 degrees. There's also a quadrant 2 answer, and this quadrant 2 answer must also have this 26.74 degrees with the horizontal, which means what is the actual angle? We can get that by subtracting from 180 the 26.74 degrees. And when I subtract, what I get is 180 minus 26.74 is 153.26. So these are the two results. Cosine theta is 0.4. Now remember, ASTC, cosine is positive only in quadrant 1 and quadrant 4. But you are finding solutions in quadrant 1 and 2, which means only quadrant 1 solution, because quadrant 4 is not between 0 and 180 degrees. So in this case it's simple. I just go cosine inverse of 0.4. Cosine inverse of 0.4 comes out to 66.42 degrees. So it depends on what kind of angle you're looking for. Now in the next example, it says find all solution for angles theta when theta is between 0 and 360. By ASTC, and this is positive, I know that my answer is in quadrant 1, quadrant 3. Now since the range for inverse tan is also negative pi over 2 to pi over 2, the natural answer that I get from the calculator is going to be a quadrant 1 angle. So I go tan inverse of 2 gives me 63.43. So that is quadrant 1. The second angle I seek is in quadrant 3. So let's draw them out. Here's my quadrant 1, about 63.43 degrees. If I draw the same in quadrant 3, this is my angle, which is 63.43 degrees. But the actual angle measured is always from positive x-axis. So it's all of this. And what is that? That's just 180 plus 63.43. So it's 180 degrees plus 63.43, which is 243.43 degrees. Then you can verify, for example, if this is correct, then tan 243.243 should be roughly 2. So it's 1.9995, and that comes out because we approximated the this first angle right here. So as a general strategy, here's what you can think of. If you're in quadrant 1 and you're changing to say quadrant 2, right? So if this is say alpha, this is alpha, then the whole angle is going to be 180 minus alpha. If you're going from quadrant 1 to quadrant 3 as we saw, then you have to add 180 to that alpha. Similarly, if you're going from quadrant 1 to quadrant 4, then this is going to be 360 minus alpha. Again, you don't have to remember these. If you draw the figure, it becomes pretty obvious where you have to go from there. Because you're either subtracting from 180, adding to 180, or subtracting from 360. Now we are going to look at composition of inverse functions. First of all, what does it really mean? Is it meaningful to say something like cosine of sine inverse 0.7? 0.7 is a ratio. When I throw that into sine inverse, what this gives me back is an angle, which is okay because the cosine function is designed to take as an input an angle. Okay, so let's try to find this using the calculator, and you would write this down exactly as it looks right here. So you would say cosine of sine inverse of 0.7, and it comes out to 0.714. Now that's using the calculator, but there's also another way of finding it, which is a general approach using triangles. Our goal is to find cosine of sine inverse of 0.7. Now let's assume that sine inverse of 0.7, let's say we don't have the calculator, we know this is going to be an angle. So let's say it is some angle theta. Now the inverse equals theta means that 0.7 is sine theta. And what are you trying to find? You're trying to find cosine of sine inverse 0.7, which is just theta. So what has this question reduced to is what we did in week 1, which is given that sine theta has a value, what is cosine theta? And we know how to solve that. You just construct a right angle, write 0.7 as 0.7 over 1, so it's 0.7 and 1. Use Pythagoras theorem to solve this. If I do that quickly, it's going to be 0.714, and then cosine theta by definition is adjacent, and that is exactly what we got from the calculator. I'm going to end this video here. Make up some problems of your own and try this example. We will look at it more generally in the next video with a few more examples, and then that would be the last video for day 1. That's the end of this one.